Hello everybody. In this video, we're going to be going through activity 322, loads. So you want to make sure that you have these materials in mind. So underneath the materials tab, there's basically these figures and tables. These are going to be very, very important for this activity in the IBC. Additionally, in the resources, you want to make sure that you have brought up the weight of materials tables, also the roof deck span load table, and also the K-series joist table. We'll be referencing those later. So moving on with the procedure, we basically have a high school that's located in Chicago, and they have this roof diagram, or roof plan shown in figure 1. And they want us to choose a steel roof deck to be able to carry the loads. So we're going to have to chase the loads to the roof beam, the joist, and then based on the uniform beam loading, we're going to then choose an open web steel joist that can carry the applied beam loading. Basically, after this practice, we're going to end up repeating this design process as well for our roof components of our Keystone Library renovation project. So let's go ahead and begin here with the importance factor. So this is a part of our snow load design, our snow design load. And so where we have that, it's PS equals 0.7 times CS. Remember, that's the slope factor. We also have CE, that's the exposure to wind. We also have CT, which is the thermal factor. And then we have IS right here, which is the importance factor. This is based off of the occupancy category. For instance, if you look at here, occupancy category 1, those are basically low hazard to human life. And the intent of failure is because this is like agricultural buildings, temporary buildings, minor storage facilities. Most of the time, we don't really have many humans in there, if any at all. And so that's why their importance factor is pretty low for that. As we move our way down, though, once we get to 4, for instance, this is like essential facilities, so hospitals, police or fire or rescue stations, emergency shelters. And so very high hazard to human life in the event of failure. And for that reason, we're using 1.2 as our important safety factor. All right. So this is the actual Chicago high school roof criteria. So you want to make sure that you familiarize yourself with this. For instance, whenever they have you going through calculating out the dead load or the weight of materials, we're going to be looking at this bullet point here. They're also telling us here that this is going to be a double span. So very important to know that too. Make sure that you go through this and understand all of this. For instance, the roof will also support a mineral fiber board suspended ceiling. That's something else we're going to be looking in the weight of materials table for as well. We also see that the roof will support the MEP, which is mechanical, electrical, and plumbing equipment. And so that's 10 PSF for all of that equipment. And then the building is located in an urban environment surrounded by other buildings. So that's in terms of our wind exposure there. So anyways, let's go ahead and let's begin. So with number 1, they want us to calculate the snow load for the low slope flat roof. And so that tells us that the slope factor is going to be 1 because the roof is a low slope. Now they do specify for the structure, we will use the following coefficients. So we've got these down here. Then they tell us use the International Building Code, the IBC, to determine the ground snow loads. All right. So let's go ahead and start by just making sure we have number 1, snow load calculation, and then our actual snow load equation here. What I'm also going to do is I'm going to start writing down some important information. So I know that CS is 1, as they were saying. I know that CE is also 1, and then CT is also 1. They mention all of those. The next thing that we're going to have to do is, in terms of that important safety factor, we're going to have to find that out. But what I want to go ahead and do first actually is talk about the ground snow load. So this will be coming from figure 1608.2. So you want to make sure that you just search IBC 2012 type PDF. And then usually this works pretty well. You'll have to find something that works for you. The school might have blocked this by the time you end up getting to that. I'll also throw some links to in the Canvas description as always as well. But then what we're going to do is we're going to go to 1608 snow loads. Then we got to go to table 1608.2. And so this is the Western United States. We've got to look at this for Chicago. So if I zoom in here, we can end up seeing that this is all 25. And so Chicago is right here. So 25 PSF is going to be our ground snow load. So we're going to want to make sure that we have that written out as well. Okay. Now, if we end up looking at for the important safety factor, that's going to be in table 1604.5. So we can end up going into here 1604.5. Risk category. So if we end up looking at this, we'll actually end up finding that buildings and other structures whose primary occupancy is public assembly. And so for a school, that is the case, public assembly, and with an occupant load greater than 300. So we are a public assembly. You'll end up seeing buildings and other structures containing elementary school, secondary school. So secondary school is high school. So we can end up looking at this. Let's see if they gave us any information for how many occupants we're going to end up having. But I will tell you that it is going to be occupancy category 3. And so for that reason, if we end up popping up here, occupancy category 3, we're going to write 1.1 for our important safety factor. So that's going to be 1.1. Okay. All right, perfect. So one of the things I'm going to keep my eyes peeled for too, maybe drop this in the comments if you end up seeing how many occupants, what the occupant load is for this high school, because I haven't seen anything for that just yet. Perfect. So we've got that guy. So now, since we have all of these values, what we can do is we can actually calculate out what PS is. So that's our design snow load. So we can end up putting that in here. Now, one of the things, too, we want to check with this is the actual minimum. So we're going to also check that out, too, afterwards. But I'm going to go ahead and bring up the TI-84 calculator emulator right here. And then I'm going to go ahead and start typing in 0.7 times, we got CS, which was 1, times CE, which was 1, times CT, which was 1, times the important safety factor, 1.1 times 25. Now, guys, keep in mind, if you have 1 times 1 times 1, you don't really need to put that in there. But what we end up with here is 19.25. And then remember, that is PSF. And so now we can look at that, right? Now, this is 19.25 PSF. Now, what we want to check, though, is though this is 19.25, we want to look at just what we had in the slides. And in the slides, it stated if the PG, the ground snow load, is greater than 20 PSF, which it is the case, right? We found out that the ground snow load was 25. Then for the minimum snow load, must be the case that PS is greater than or equal to our important safety factor multiplied by 20 PSF. So in this case, we can end up finding out the minimum snow load here, right? So if we have 1.1 and you end up taking that times 20, as you guys can already guess, it is 22. So 1.1 times 20, it is a case where it's 22. So PS actually has to be greater than or equal to 22 PSF, and that's the minimum. So actually, we want to end up using 22 PSF for that guy, right? And so remember, this comes from slide 10 of our 322 loads and load paths presentation. All right, perfect. So that's what we got for that guy. Let's go ahead and move on to question number 2. So question number 2 here, they're asking us to find the roof live loading required by the IBC. So what we want to end up going to is if we bring up the IBC. So just as we said here, we want the roof live loading. And so we can find the live loads category here, section 1607. Basically, we're going to be in chapter 16 for pretty much all of this. So 1607, it says live loads. Now, what I want to do is I want to go through here. Let's see something that ends up telling us the live loads. And so if we end up going on here, we have the occupancy or use. And if we keep scrolling down here, we can take a look at this. I'm looking for something with like flat roofs here, because that's what we're dealing with. I got some stuff deleted. Interesting. Wonder what that was. So let's hear 1601 continued. So let's look for roofs, perfect roofs, and then ordinary, flat, pitched, or curved roofs that are not occupiable. So yeah, we aren't going to have anybody actually up there. So perfect, 20 PSF. So 20 PSF is what we're going to end up going with. As you can see, the uniform PSF. And so what we can write down here for number 2, per table 1607, per IBC 2012 table 1607.1, required live load for roof. We'll put that for flat roofs. And then that's low slope. You want to keep that in mind too, because it's not actually flat, is 20 PSF. And then I'll unbox that answer there. Okay. So that's what we just end up finding there, 20 PSF per table 1607.1 in the IBC. All right, let's go ahead. Let's move to question number 3 here. So question number 3, they say use the weight of materials tables to estimate the dead load of the roofing system by estimating the weight of all roof components. Now, they do have a note here. Typically, the ceiling and mechanical, electrical, and plumbing will be supported by the roof framing and not the roof deck, but conservatively include these loads for all roof calculations. Okay, so we're going to go ahead and bring up the weight of materials table. The other thing that we're going to want to do is remember up here, they end up telling us all of the materials for our actual low slope roof there. So what I'm going to do is I'm going to actually write this down. So I'm going to go materials right here. And then I'm going to go ahead and do this. So we have the built-up roof. So I'm going to go ahead and write that down, built-up roof. And that's the BUR, B-U-R, or BUR. Now we have, that is going to have some value, right? We're going to also have 2, which is the 5 inches of rigid insulation. We're going to also have 3, which is the actual steel roof deck. Then we're going to also have 4, which is going to be that 5/8 inch mineral fiber board suspended ceiling. So we're going to also include that. And then also, of course, the MEP. So they have 10 PSF for that. So I'm going to go ahead and let's put these guys. Let's see. Let me make sure that I'm having enough room. So 5/8 mineral fiberboard. So we write down 4 there. 5/8 mineral fiberboard. That's going to have some value. And then we got 5 here. And then that's going to be the MEP. I'm going to go ahead and write this one out. 10 PSF. And that's assumed. That's what they end up telling us. So we're going to write that assumed. So we've got that there. Now we've got to go through. We've got to find these actual ones. So 5 inches of rigid insulation. We've got the built-up roof, BUR, and then we also have the steel roof deck. Okay. So let's go ahead. Let's pop into that weight of materials table. And so let's go ahead and start off with the built-up roofs. I'm just going to type in built up. And so as we can see here, roofing material built up. What they tell us for this material is that the PSF is 6.5 PSF. So we're going to go ahead and write down 6.5 PSF on there. Now, what we want to look at next here is next we want to look at our 5-inch rigid insulation. So what we can type in here is rigid insulation. Now, as you can see, this is per 1-inch thickness. And so basically what we've got here is 3/4, right? 0.75. So 3/4 of a PSF multiplied by, we've got 5 inches of that, right? So what we're going to end up with here, we go 0.75 times 5. We're going to have actually 3.75 PSF for this guy. So we can go ahead and put this down here, 3.75 PSF. Now, in terms of our steel roof deck, we're going to look at that too for our weight of materials tables. So we can go ahead and type this in, steel roof deck. Now, let's see here, steel roof deck. Okay, perfect, steel deck, there it is. So that's going to be 3 PSF. So what I'm going to go ahead and do is write down 3 PSF for that guy. Then now we've got that 5/8 mineral fiber board. So now I'm seeing this mineral fiber board, 5/8 inch, perfect. And then that's telling us that that is 1.4 PSF. And so now in terms of that total here, so this is question number 3. So in terms of that total dead load of the roofing system, so I'm going to write roofing system total dead load. That's going to be that 6.5, basically the sum of all these, right? 6.5 plus 3.75 plus 3 plus 1.4 plus 10. What we end up with is 24.65. So this is approximately 24.65 PSF. So we'll go ahead and round that up just to play it conservative as well. So we're going to round that up to 25 PSF. So if we're going to end up doing. Okay. So 25 PSF is what we'll end up getting for that roofing system total dead load there. All right. So let's go ahead and let's continue. So question number 4, they have determined the total design load. So this is the dead load plus the live load for the roofing system here. So the equation that we want to end up using for this, and I might end up getting actually another piece of paper, but the equation that we want to end up using is the total load combination, or we can write this. Let's do that. I'm crossing that out. So I'm going to put my initials and also my the date. So the load combination that we're actually going to be using here is the dead load plus the live load, plus they have LP or the snow load or R, which is the rain load. So LR, sorry, that's LR. That's the roof live load. And then we have S, which is the snow load, and then R is the rain load. So we get to choose one of these 3 here. So remember, this is where D is the dead load, L is the live load, and then LR, once again, roof live load, S is snow load, and then R is the rain load. So only LR or S or R is required. It's not all of these being required, right? And so since S, which is PS up here, PS was the design snow load of 22. We're going to end up using that. So S is what we're going to end up plugging in to this side here. So in terms of that load combo, that load combination, what we're going to end up putting in here is going to be the dead load, which we just found to be 25 PSF, plus the live load. That's going to be 0 because it's no live load other than the roof live load will affect the deck or the roof beams. So we're going to put 0 PSF for our live load here. And then we're going to have plus 22 PSF because that was our snow load there. And so whenever we add this up, we're going to end up getting 47 PSF here. All right. Alrighty, perfect. So that is 1 through 4 so far there. I'm going to go ahead and grab another piece of paper and we can continue with number 5. So moving on here, we've got question number 5. Now they want us to select a steel roof deck. Now it is given that it is double span, right? So we're spanning these two guys here. And we also see that the clear span is 7 feet here. And that's to support the required loads that we just ended up calculating out, right? And so just as we said there, we've got a total load combination of 47 PSF. And so that's going to be that design load we're going to need to carry. So if I end up going into here, we can end up looking at this guy. So they've got all these dimensions here for us, but what we want to be looking at is the double deck span. And then in terms of that clear span, we need 7 feet, right? So if we go back to this, you can see in this diagram, it's 7 feet for that clear span. And so if we end up going down here, so we got to go to these 3 rows here, and then we got to go to this column. Now what we're looking for is the first number that is greater than or equal to our 47 value. And so as we can see here, we've got 48 here. And so what deck type is that? That is type 20 there. And so what we want to end up doing is we want to put down here per roof deck load span table given 7 foot deck support spacing, or you could say that as a clear span, and the double deck span, that is. So we can put that in there too, double deck span. Remember, we got to put the initials on there and then also the date. So double deck span, we will select type 20, given we have a load combo of 47 PSF. So type 20, so double deck span, type 20, and what do we say? Given a total load combo of 47 PSF there. Perfect. So there we have it for question number 5. We're going to go ahead and move on to question number 6 now. So question number 6, let's go ahead and take a look at that. So determine the roof beam loading for both the interior and exterior beams. So we've got to look at this over here. Now, in terms of our interior beams, those are going to be these 2 guys here. The exterior beams, those are going to be these outer guys here. Now, in terms of this, we are going to be looking at that tributary width, and we're also going to be taking into consideration our load combo. Now, our load combo is 47 PSF. So we're going to end up using that for the load combination, right? And then we're going to multiply that by the tributary width. So if I end up looking at this, let's calculate this out first for an interior beam. So we can end up writing down interior beam. So for that interior beam, that's going to be equal to, remember, our tributary width multiplied by the load combo. Now, just as we were saying, our load combo in this case is 47 PSF. And so now in this, so the uniform beam loading here is going to be equal to, if we have the interior beam, it's going to be from here, halfway is 3.5 feet, right? Then we also go halfway here, another 3.5 feet. So that is 7 feet. So we've got 7 feet for our tributary width for the interior beams. And I'm going to underline this too, just so that we know. So interior beam, we got 7 feet times our 47 PSF there. So if we take 7 times 47 PSF, what we're going to end up with, now remember guys, this is pounds per square foot multiplied by feet. That's going to actually cancel out one of the square feet on the bottom. So we're going to be left with just PLF per pounds per linear foot, or you could do this pounds per foot. Once you multiply these out though, we're going to end up with 329 pounds over feet. And then what I'm also going to end up writing over here is I'm going to put down uniform beam loading, because that's actually what we're calculating out there. So the uniform beam loading for the interior beam, 329 pounds per feet. And then now what we can also do is we could do this for the exterior beam. So remember, the exterior beam, it's going to be a little different, but we're still using the same formula here, right? So tributary width multiplied by the load combo. The load combo in this case is 47 PSF. So for our exterior beam, we're going to end up taking that load combo again. Now the tributary width, that's what's going to differ, right? It is only carrying half of the tributary width because there's nothing over here on this side. So this beam out here actually is not going to have to carry as great of a load. So tributary width here, we can write that down. Tributary width, that's going to be equal to 3.5 feet, right? And so now whenever it comes to calculating out that uniform beam loading for this guy, it's going to basically be half of this, right? Because we have 3.5 instead of 7 times 47 PSF. And whenever you calculate that out, you're going to end up with 164.5. And then remember, that is pounds per foot. The other way you can write that is PLF. So instead of PSF, pounds per square foot, pounds per linear foot, PLF. That's what you can end up using there. So that is question number 6. Hope that was helpful. Let me go ahead and move on to question number 7. Now for question number 7, we're bringing this down here. We're determining those open web joists to act as the roof beams. Now they do tell us use only the top load values in our table for that K-series joist table. They also say, note, assume the roof deck will be installed with a triple span. And so what I want to do is I'm going to go back up to here. And it's very important that we look at this roof plan. Now, the interior beams, we do have column lines 8 and 9. Now, as you can see, that clear span is going to be 16 feet. And so what I'm going to do is I'm going to go ahead and write down number 7 here. And then what we want to do is we want to go ahead and go beams, span, column, line 8 to 9. And then we're going to end up putting down 16 feet for that guy. So 16 feet, okay? That's equal to 16 feet. Now, what we can look at are going to be the interior beams as well as the exterior beams for this. So let's go ahead and let's go interior beams. So now for these interior beams, this is going to be on the inside here, we do have that load of 329, right? For our exterior beams, it's a bit lighter of a load. So for these interior beams, though, we want to look for 329, and then keep in mind our span here is 16 feet. So if we end up going into here, we can end up going down to 16 feet. And then what we want to do is we want to keep looking at this, and we want to end up finding something that will end up working for our 329 pound per foot uniform beam loading. So we can't do 246. We also can't do 313. First one that we encounter here is 380. So what we're going to go ahead and put down here for the interior beams that are between column lines 8 and 9, we're going to choose. So we're going to choose 12K1 designation. And then what I'm going to put in parentheses here is that 380 pounds per foot. That is greater than the 329 pound per foot. So that uniform beam loading that it can withstand is greater than the actual design load there. So that's the interior beams between column lines 8 and 9. Now we can go to the exterior beam. Now, just as we were saying here, the exterior beams on this, it is going to be a lighter load that they have to carry, right? 164.5. And so now this is where, you know, the engineers, you might end up having this first joist designation where it's 8K1. I'm pretty certain that this first number is in terms of the depth. Yeah, as you can see here, it's that depth. So some engineers, they might end up seeing this where it's 8K. They might not want these beams depths to actually differ just for visual aesthetics. And so if we look at this in terms of that span, it's still 16 feet, right? For that interior beam, we're talking about this guy right here and then this guy down here. So the load that we need to be able to safely carry, let me bring this guy back up, is 164.5. And so if we end up looking at this, we go to this, you'll see that, you know, 8K1 could work. So according to the joist table, we can write this down too. We can say 8K1, choose 8K1 designation. And then what we can do is we can put in that 246 pounds per foot is greater than the 164.5 pounds per foot. However, you can specify or choose 12K1 right there, right? Just so that we have a similar depth and avoid a large number of varied joist depths. So it's 12K1, which 12K1 is 380, so 380 pounds per foot, which is greater than the 164.5 by quite a bit, right? To provide similar, and definitely spelled that incorrectly. It's the reason why I'm not an English teacher. So similar depth and avoid large number of varied joist depths, right? So I'm going to say that we're actually going to choose 12K1 for this one and then also for this guy. So we're going to remain consistent with that. Now, why is that too? If you end up looking at this, you'll see that we're going to have a 20-foot span for these next beams that are in between column lines 9 and 10 in that case. So we can go ahead and write this down. So, I'm just trying to play this safe so that we keep it consistent and there's not too much variance between our beams depths. So we're going to go beams spanning or span length beams on column lines 9 to 10. Span equals, we're going to underline this, column lines 9 to 10. Span is going to be 20 feet there. So you got 20 feet span, 16 feet span up here. Now these are 20 feet spans here. And then what we're going to end up doing, so we're going to calculate this out for the interior beam here. So interior beam. Now remember, the interior beams, those are going to have that 329. The exterior beams are going to have the 164.5. So let's go ahead and let's find that for the interior beam. Let's choose our designation. So we're going to go back to the K-series, and we're just looking at this top number for now. So 20, and then we can see, so we're looking for a value that's going to be greater than 329. And so as we're going through here, well, 12K3, looks like 12K5 is a possibility here. We also can end up looking at this, so we can go through here. Let's see, we also had the 16K as well. So we could end up going 16K2 if we would like to. What I'm also noticing, so if I end up going through here, so we're at 20 feet and we had 329. Now if I go here, 409, the approximate weight, so pounds per foot, is 7.1. Now, as you all can imagine, just as we were talking about before, as the weight increases, the cost is also going to increase. So that's 7.1. That's why I'm not going to actually choose 12K5. Now, if you were looking for the aesthetics of this, right, where you wanted to have all your joist depths be matched, you could end up going with that. But just know that it's going to be more costly. I'm going to go for something that's more cost efficient here. And so if I go to the 20 feet here, I can also look at this guy. So this is 6 pounds per foot for that. But if I end up going with this guy right here, that's actually going to be 5.5 pounds. And so that's why I'm going to choose the 16K2 designation. So I'm going to put down here, choose 16K2. And then we're going to put down, that's 368 pounds per foot that it can carry. And that is greater than our 329 pounds per foot that we needed. And I'm going to say, because it is the lightest joist that can carry 329 pounds per feet in the table. And then I'm going to put on here, but you could also choose what was that, 12K5, right? 12K5, yeah, so 12K5 to avoid varied depth. So if you really wanted to focus on, not varying the depth, choose 12K5. If you're focusing on more cost-effective, 16K2, because that is a lighter beam. So that's what I'm going to end up choosing. Now, in terms of that exterior beam, we've got to go through this guy. We're almost done here for this first part. This is the last little calculation, our last designation that we need to end up making. So according to our load span table here, we need to be able to get something that is at least 164.5 pounds. So if we look at this 20, actually the 10K1 ends up being satisfied. If you also want, you could also end up going 12K1. It does look like that is the same weight there. That will also ensure that you do not vary the depth too much. Let's see what else could be options. Since we already also since we already chose the designation of 12K1, that could be pretty good for this guy exterior beam, because we already have it being used up there. So that could also be a pretty good reason. Or if we also want to provide the same depth as the interior beams, you could end up choosing the 16K2 as well. Just know that it would be quite a bit of excess of that. So we can end up putting all these down. So according to the joist table, the first option we run into, so 10K1 is a safe option. So it's 10K1, that was 199 pounds per foot, which is greater than our 164.5 pounds per foot. Or we can put down 12K1. 12K1 works because that's 241 pounds per foot, which is greater than our 164.5 pounds per foot, and same weight. As the 10K1. But since we already, and so that would work well too, because, we can put that down too. That 12K1 was already used previously. And then what we can also do is alternatively use 16K2. And then in 16K2, that's 368 pounds per foot, which is greater than our 164.5. To provide same depths. As the interior beams, right? So, I know that we've kind of bounced back and forth a bit between these, but these are all the thoughts, all the things that the structural engineers will keep in mind as they're going through and choosing their beams that they're going to end up using. And so you guys can kind of rationalize this out, decide which beams you're going to end up choosing to use for this. And then also, once we get into part 2 of the video, I'm going to go through the actual calculations to find out what open web steel joist we're going to use for the Keystone library. And then it's going to be completely up to you for you guys to make that decision, what web joist you're going to actually use based off of the given options that we calculate out. Anyways, I hope this video was helpful. Catch you all in the next video. Bye-bye. See you later.